My apologies. There was a little bit of confusion with getting a camera set up. I'll have that set up for my next session. Good morning, good afternoon, good evening. My name is Jeff Fritz. I'm a principal program manager at Microsoft. I work on the .NET and Visual Studio teams with a focus on community, and particularly with a focus on Blazor and live events. So training and being involved in these types of things is right up my alley. So I want to talk to you today about the next generation of user interface, what we're really pushing, what we're promoting, what we're saying is going to be, and what we believe is the next hotness, where you want to be building applications, and that's with this framework called Blazor. So let's talk a little bit about what Blazor is, why we think it's really the next generation stuff for you to use, and what you can do with it today. Now, this is a very beginner session. This is going to be very much talking about how the technology works, how you can get in and get started with it, showing a couple of examples, but very much getting in at the beginner level. I have a session a little bit later today where we're going to get in, we'll be a little bit more advanced, talk about building components and building some more complicated things to work with Blazor. So let's talk about, let's get through some of the slides, thank some of our sponsors and exhibitors. Blazor's built on this thing, it was initially built on this thing called WebAssembly. Well, WebAssembly, that sounds like a throwback. That sounds like something right out of the 70s meets 2021. What is WebAssembly? So according to webassembly.org, abbreviated WASM, WebAssembly is a binary instruction format for stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. That's a lot. But let's boil that down. What does that mean for us as developers? It means you can program with your favorite programming language, and if it can compile to a different runtime target, we can deploy and run in the browser. Let me say that again. You can build with your favorite programming language and compile it to run in the browser. The browser typically, right, is where we have JavaScript running. If you want to write code that runs in the browser, back in the day you wrote Java applets, right? You wrote an ActiveX control back in 1998, right? You wrote Flash components. I see a couple folks smiling going, yeah, we did that. You might have written Adobe Flash at one point, Shockwave, right? We had all these different formats, but they were very proprietary. They were things that one vendor would support, and there were extensions onto HTML so you could embed and drop those components into your web pages. WebAssembly is not an extension. WebAssembly is part of the HTML5 standard. So whatever phone you're using, whatever device you're using, if it's working with a modern browser, it supports WebAssembly. So what's that mean? What can we do with this? Well, WebAssembly, since it's binary code running in the browser, it's not interpreted. So it makes it efficient and fast, okay? Because we're loading binary data, binary applications in the browser for it to execute. And we've learned from the running of the JavaScript runtime in the browser, and now WebAssembly, WASM, runs in the same memory-safe sandboxed environment. So anybody who goes and deploys an application that runs in the browser on the client, they don't have access to things like the file system, right? They don't directly have access to things like different sensors on the device. They only have the ability to edit what's inside the browser frame. And that didn't resize properly. So it integrates with the features you already know. And it's part of the open web platform. These are things that we know how to build and work with as web developers. So we can continue to push and develop web applications. We can integrate with JavaScript, and we can continue to innovate with WebAssembly. So I mentioned everybody's browser has this. Do you remember Spectre and Meltdown? It's been 4 years since this thing happened, but back in 2017, there was this vulnerability that was discovered in basically every processor, right? I'm not going to get into how that vulnerability worked, but what it did do was it forced every operating system vendor and every browser vendor to release new versions and push updates to everybody's phone and everybody's machine. Every operating system was updated. But what that delivered was updates to the browser to support JavaScript patching, and it also came with WebAssembly. So even our relatives who don't keep up with patching their machines, right? Here in the States, whenever I go visit my family on Thanksgiving weekend, I end up being that family IT guy and applying all the Windows updates, applying all the updates to their phones, and making sure that everybody's secure. I don't want my mother-in-law to inadvertently get her machine attacked, right, by somebody who's exploiting an unpatched version of the operating system. So we do these things, everybody's patched up. Well, now folks like my mother-in-law and my non-technical family members, like my mother-in-law, they've all got the ability to run WebAssembly. Okay, that's something. That means I don't need to go and install clients and patches and things to get this working. But why not use JavaScript? Why use WebAssembly instead of JavaScript? I've already got so much written with JavaScript. Well, the folks from the WebAssembly group, they say WebAssembly can be natively decoded much faster than JavaScript, can be parsed with experiments showing a 20 times performance improvement. Okay, now we're talking. Now we're getting somewhere. All right. WebAssembly can be targeted by many different programming languages and frameworks. So many of us in this room, we're .NET developers, we're C# developers. I can build with C# and it works in the browser. But there's all kinds of other languages that are enabled to work with WebAssembly also, like all of these. So now the browser is not just a JavaScript playground. There's some crazy languages up here. Poetry, Prolog, Rust, Zig. I've never heard of Zig, but it was on the list from the awesome WebAssembly languages website, and I dropped it in here. Kotlin, assembly script. What's assembly script? But that works. You can do this, okay? So let's take a look at some demos from the awesome WebAssembly website of just how WebAssembly works in the browser and what this performance bump means. And then we'll take that over and start looking at how we can use that with Blazor. There was a notes page to go with this. Because my notes, no matter. I'm going to go over here. So this is the awesome Blazor website that has all kinds of Blazor demos. But what I want to show you is over here. Nope, where'd that browser go? Are you kidding? This is Doom running in the browser. I'm going to show that one in just a second. But there's also Diablo working in the browser. And I actually had this running a few minutes ago. But this is Diablo running, built with Blazor, okay? Recompiled and running in the browser. So back in 1997, the folks at Blizzard North built this game, Diablo. And it's been recompiled, runs on .NET, live in the browser, and I can log in. Of course, I'm gonna log in as C# Fritz because he's quite a mighty hero. And I can get back to running around in Tristram. And on this machine, it renders and I can play, I can interact with the game, and it looks and feels like it did back when I was in college in '97. So we've got a little bit of power now in the browser we can work with. I'll go over to that other demo that I brought up. Because whenever there's a sufficiently sophisticated new technology that folks want to brag about, hey, look what we can do on mobile device X, on tiny screen Y, they run Doom. We can run Doom. And it will load up and run in the browser. Okay? So this isn't just something simple that we're going to use to manipulate forms and data. But the power of these very high-end games running and animating live in our browsers really tells you something that we can do impressive things with this. This is all running locally on this machine. I'm not going back to a server and downloading video content and presenting it. It's downloaded the DLLs, the binaries, the map packs, and it's running it in the browser. So we've got this step that we've taken where, and I'm not going to get into actually playing the game here. The intro takes a little bit too long. But we've stepped into a place where deploying and building applications that are going to run on our phones, our tablets, and our workstations, now the promise of, yeah, do it with the web, now we can do a whole lot more live in the browser. So this is the awesome Blazor list being maintained out on GitHub from Adrian Torres. I'll have a link to this at the end of the presentation. So, okay, there's a lot we can do there as we look to move forward with our applications. So how does Blazor work? What exactly does Blazor do for us in the browser? So our typical browser is there on the left side, and our servers usually run on some sort of data center, or they're hosted in a nice blue, lovely shade of blue cloud, and you get and fetch data back and forth from it. And hopefully you're running ASP.NET Core because it's the fastest commercial web framework available in your fluffy blue cloud, and you're sending data back and forth to the browser. And the way that most folks who want to build an interactive local application in the browser, the way they do that is they'll use one of these, Angular Reactor View, on top of the JavaScript runtime in the browser, and they're fetching data from services, microservices that are running out in their data center. So as a C# developer, I want to be able to move forward and use Blazor. I'm going to replace all those JavaScript frameworks that are running and replacing the contents inside my browser. I'm going to replace it with Blazor so that instead I'll deliver all my DLLs instead of all JavaScript libraries. I'll deliver DLLs into the browser. They'll load up and render content, and I'll fetch data as needed from the server. It's quite magical, you might say. So Blazor, we can build client-side web UI with .NET instead of JavaScript. It compiles down and runs in the browser. We can write reusable web UI components with C# and Razor. We know how to do that. We've been doing MVC for 13 years. So Razor's pretty cool. I'm very familiar with that. Share .NET code then between client and the server. This was that key feature that so many of our friends that went to JavaScript, went to Node, loved, because they could take their logic they had in the browser, move it to the server, and it was the same language both on the front end and in their back end services. We can call into JavaScript libraries from Blazor as needed. We can reach in, we can execute those. We have to request and put a little bit of configuration in there, and it will work. Now, Blazor works on either the client or the server. So when it runs in the browser, we have Razor components that run on top of a .NET framework that compiled down to WebAssembly. And this is just like it runs on Windows, Mac, or Linux. You have your .NET application that you built with C# and whatnot, right? WinForms, WPF. It compiles down, runs on a .NET framework that runs on a runtime built for that operating system. Well, in Blazor, it interacts with the DOM. With Blazor Server, same type thing. We have our Razor components in .NET. Well, they run on an ASP.NET Core server out in the cloud or on a hosted service in your data center, and they send data back and forth to the browser using SignalR. SignalR is our live communication technology that provides live updates using WebSockets or a series of other technologies that it will step down through. Okay. So we have some options. We have two different choices of how we want to build our application. Now, Blazor WebAssembly was released with .NET Core 3.1, and it's available going forward, so it is also available in .NET 5, and it's being updated for .NET 6. Blazor Server was first released with .NET Core 3.0. It's part of all the versions since, so it is part of a long-term support instance with .NET Core 3.1. All right. Now, why would you choose one over the other? I changed my font back. That's really hard to see for the folks here in the room. Blazor WebAssembly is great for offline support or progressive web apps. Zero latency in the user interface because all the code is local in the browser and working, which also means you can host it as a static website. And I have a session tomorrow morning talking about Azure and static websites with Blazor. I hope you come back for that one. Blazor Server, though, because we're rendering all of our components on the server, makes it really good for thin clients, right? If you're interacting somewhere where they don't have very good network connection and you don't want to have to send a lot of content down into the browser, you can use a very thin client, run with the full ASP.NET runtime on the server, and all of your code is on the server as well, right? Haven't you ever wondered with JavaScript applications why people don't go through and just edit the JavaScript code live in their browser? Well, you're pushing all of your DLLs down into the browser with WebAssembly. With Blazor Server, all of your DLLs, all of your intellectual property stays in the data center. It stays on the cloud somewhere that you have full control over, and nobody gets access to those binaries. Okay. So let's get started with Blazor. Let's do some of the basic getting started things. Let's actually run an application and go through and take a look at this a little bit. So you can download and run the .NET 5 SDK for Windows, Mac, or Linux. Once you have that installed, and there's great instructions from Blazor.net or from get.net, that website, get.dot.net, and you can run .NET New, Blazor, WASM, and just .NET run it. Now, I'm going to show you a little bit of this with .NET 6 today, so we can see some of the new features that have come along as part of Blazor here. So the machine that I'm running on, this is actually a Linux machine running Kubuntu Linux. It's running KDE on top of Ubuntu. So let's head over and take a look at our first Blazor application. We're going to take a look at some other demos along the way here. So I am going to, let's go over here, and let's open a terminal. So I already have .NET installed here, so let's go into my dev folder, and we're going to create our first application, .NET New, Blazor WASM, and let's call this DEVint first, -O, there we go. So this is creating a new Blazor WebAssembly application and writing it into that folder. So I'll go into that folder, right? And let's just .NET run. Just run the application and see what we get, and let's peel this back a little bit and dig in. So let me open browser for this. There we go. No, you're not gonna. There we go. Localhost 5000. And there we go, hello world, and I've got an about link in the top left, I've got a counter nav item on the left, a fetch data nav item, and I've got this little survey thing in the middle. How is Blazor working for you? Please take our brief survey. There's a couple things going on here, but this is all running in the browser. Look at this. I hit F12 to bring up my developer console, and it says Blazor loaded 8.6 meg resources. 8.6 meg just to run hello world. But what it's doing is it's downloading that .NET runtime. It's downloading my application and putting that into application, it's putting it into local storage here, and we're able to see it right there. These are all the things. Now, when I'm running in development mode, it's delivering all these DLLs because it's running locally. When we publish and we ship these out for anybody on the web to interact with, it's actually going to link them in tree shake, so it doesn't send all of the content. So you don't see 8 meg loaded out there. However, I tried taking the Pepsi challenge and comparing to other websites. Well, how does 8.6 meg compare to other locations? And I went and looked at places like YouTube and Twitch that they're doing a lot in the browser. And it turns out that they load a little bit more than that in JavaScript libraries when you first go to their websites. And they load it every time. They don't cache it like Blazor does. This is sitting in local storage. It won't ask for it again. And I can actually see, right, it loaded 8 meg from cache, loaded 0.04 meg over the network. So it didn't go and load all that content again just for opening the application. This is a good thing. This means that it's going to load and manage and behave properly for us. How we doing over here, Teams folks? We all right? I'm looking for one of my techs. I don't see anybody. I'm going to assume we're doing okay. So there's a couple things going on here. Let's look at the counter first here. This is a very simple, click this and it increments. Big deal. So what? What's it doing there? It's incrementing this number, but it's doing it with C# in the browser. I've loaded these DLLs, right? And if I open this back up and show you the list of DLLs, right? Look, Microsoft ASP.NET Core, Microsoft extensions, C#. It even loaded some components to Visual Basic here. But if I keep scrolling down, it's going to stumble into, right? Look at all these system runtime, system security bits, threading, and .NET WebAssembly. Come here, you. Did I miss it? Did I miss it? I should see DEVint in here. There it is. DEVint first DLL. There's my application, and it's only 17K. And that's running out of it. Let's go over and take a look at the code that's actually driving this. So let me run tmux so I can put this here, and we'll just .NET Watch over there, and over here, we'll open Visual Studio Code. So there it is running on the left. Here's the application. If I go look at that counter, here it is. Okay, let's close this. So I have this little increment count method that is called, and it fills in that current count right there and updates it. And I have on my button, I have this little onClick method, and that looks like a JavaScript onClick. It looks like a JavaScript onClick, but it's got the little @ sign in front of it. The @ sign tells the Blazor runtime, this is C# code. This is a .NET method that you're going to execute when that button is clicked. And it's going to execute the method increment count. And increment count is right here. Okay, so there it is, and when I click it, it does current count +1, and it refreshes that number. Now, one of the features that we've been touting that we say is so great that's coming as part of .NET 6 for Blazor developers is this feature called hot reload. Now, think about it. This running in the browser is, it's got a DLL there. For me to hot reload something means I need to shut down the application, patch that DLL, and restart it. Well, we can do it without patching the DLL. I will save, and it'll refresh. You see a little thing popped up there, updated the page, and now it counts by 5s. And if we go back in here and change this to, let's make it really dramatic and go by 100, and now it increments by 100s. So the simple updates in here, right, save, and it refreshes. So now, as a .NET developer, right, as an ASP.NET developer, you're used to, I've got to rebuild the application, I got to wait for it to load, right? And the whole edit and continue experience just was lost for how long? Now, right, I have .NET Watch running in the background on a Linux machine running Visual Studio Code. I did this on purpose for these demos because I wanted to show you that this is not just a Visual Studio thing. This is something that everybody can do, Windows, Mac, and Linux, and build your Blazor applications and be successful. I'm running in Firefox on a Linux machine. There's no Microsoft tech here except for .NET, okay? So these are things that make us as Blazor developers, they empower us, they enable us to do more, to go to different places. And this application doesn't have any moving pieces on the server. These .razor files are my Blazor components. They're my pages that specify here's what you're going to present when we navigate to the various locations. So this @page counter you see on line 1 here, that tells the Blazor runtime, you're going to display this content when we navigate to /counter. But pages in Blazor are also components. And a component in Blazor is something that we can reference, that's another .razor file that we can reference with a tag. So this kind of makes sense. I've got a survey prompt tag here. Let me bump that up. So I've got a survey prompt tag, and there is a survey prompt .razor over here. So I have a tag that has the same name as the .razor file. And when we look at that, here's that div that says, please take our survey and tell us what you think. This is garden variety HTML, Razor. We're used to seeing this. We know how to do the pivot back and forth between HTML and Razor syntax. We already know how to do that because we've been doing it for 10 plus years. But now we're taking it a little bit further by making this .razor file, which has a little bit more features than what you're used to seeing in Razor templating. Now we can do things like add this code block that we see down here on line 12. Now we have the ability to, instead of adding functions like we did in Razor templates for ASP.NET Core, now we can add additional code that enhances the behavior of the component. So here we've added a parameter with that parameter attribute above this. It's a parameter for this component called title. It has get, set, and string. We're used to seeing this. It's a garden variety. It's a typical C# property. But what we can do with that then is over here on the index page, I can now apply that parameter as a tag attribute. I can fill in some content that gets passed in as a property, and when it gets rendered over on the survey prompt, it places that title right there on line 3, outputs it, right? And that's something you would kind of expect. That's something you're familiar with in using Razor. So let's take this a little bit further, right? That's my survey prompt. I mentioned that every one of these is a every one of these .razor files is a component. So let's remove that. I'm going to go back to my home page here, save, and it's gone, okay? Do I have auto save turned on? So I should be able to change this, and it'll automatically refresh and update because I have auto save turned on. I'm not even myself, Control S, working on this. So now I can add that same counter component that I have counter over there, and it appears on the page, and I have this with the +100 sitting there. I can go further and wire up a parameter over here so that I can change the increment up, right? So let's set this up as, right, parameter. I'll use the public int, I'll call this increment. Get set. Let's hide this. There we go. It recompiled properly. I'll take that increment and I will default it to 1. And instead of plus minus 100, I will say plus equals increment. And now if I go over here, this isn't working. Why isn't it working? Increment equals 1. What did we do? So what we can do is we can also force the reload. So it loads up brand new content. Let me make sure. Yeah, there it goes. Now it's counting. So let me go back to here, and if I go to my index page, I can extend that counter now to say increment equals, now let's add the 100. Refreshed, and it updates. So I have this very rich parameter feature that I can use to pass data back and forth between components. Now, those that are using JavaScript and Angular, Vue, and React, they use fetch to go and get data from various microservices for interacting with cloud services, right? You may want to use Azure Search or Azure Storage to store content that you want to fetch and present on screen, or you want to execute a search operation, bring back the results, and paint that on screen. Well, the fetch data sample here shows this very basic interaction that will allow you to get data from somewhere else and paint it on screen. And as .NET developers, we already have a component that does this. It's the HTTP client. So just like we can in ASP.NET Core, we can use the inject directive that we have there on line 2 to inject an HTTP client into our Blazor page, into our Blazor component. And our code then can go out and get from some service, right? It's going to go get some JSON and return it as an array of weather forecast items. Now, the weather forecast is this little class right here. So we've written a class that lives inside of a Razor file that runs in the browser. We're going to go fetch data from this .json file, put it into this forecasts array that we see on line 38, and there's a little for loop here that outputs the content on the right. So we have a way to go fetch data, fetch it in whatever format you want, format it however you want because you have access to all of .NET. JSON is a handy format, real easy to work with, and paint it on the screen. Make decisions what you want to do and make it appear appropriately. That's not bad. We can start to get really creative now. So we have some samples out there, some other applications that we've been going through. There's a great to-do list example available for you out there that you can take a look at and wander through and see how things fit together. But I want to call back to the Blazing Pizza demo that's part of our workshop, and we gave the Blazor workshop yesterday here at DEVintersection. Let me head over to the console, and I'm going to go start that application. So this is available on our GitHub. There we go. Yes, .NET run this one. There we go. So it's not just a sample application like this, but we can do pizza shop. It looks and feels a little bit like a typical storefront you might go to online in order to order pizza, order something from DoorDash or wherever to be delivered to you. So I can go through, and I really like pepperoni pizza. If I'm going to order this for my family, let's make this a little bit bigger. And I like to put some bell peppers on that also. All right, we can place that order. It appears over on the side. I can place that order. It'll prompt me to log in. We have security available for Blazor. It works all the way through from your ASP.NET Core server into Into Blazor, we can use OIDC if you want to authenticate that way as well. So let me log in as me, see if I remember my password. See if I remember my password I set up for this. Nope, I didn't. I'll give it one more chance, one more try. Nope, I forget my password. That's fine. Register as a new user. Sure. I'll log in as this. There we go. It's not wired up to email, so map component live in the browser. So this is not just simple demos. There it is, getting closer, right? We can do a bit of tech with this. We can actually get outside the box here and build full web applications with this, okay? There we go. Delivered, and there's the delivery location. Why am I getting... I'm not sure why I'm getting that video blip. So, all right. Those are the typical examples that we'd like to show about this. We also have the ability to do static websites. I mentioned, right, we can do, because this is all DLLs being shipped down and running in the browser, we can run this on top of just static HTML. We don't have to have things running on a server. You may want things running on a server, so we can do that with Azure Functions, right? Those are very small little blocks of code that sit on the server, execute, maybe query a database, return some data, paint it on the screen, and then we're not managing servers at all. We're now just managing the application that runs in the browser. So I wrote a little application that shows this off because I thought it would be something fun to do. So you might not know this, but I like hats. I really like hats. I really, really like hats. I've got more than 120, 130, and I wear a different one on every video stream that I do. And I've loaded about 60 of them onto this website with a little bit of CSS. But this is, it's just a website that shows some of the hats. But this is all taken, presented, and running native in your browser. So I can go up here and I can search for, right, I have a handful of Penn State hats. So that search is all running in the browser, formatting and relaying out the screen. It's doing a query back to an Azure function to go get the data out of the database and present that information. So I'm not actually running a server here. Once that data is delivered to you, it's done. It doesn't go fetch anything from the server. I load up those images from Azure Storage, but I'm not going through all of this challenge of loading up where all my data is every time, right? I load it once, it's sitting here in JSON, right? Here, there's a SpaceX hat, and I can search for and bring that up. DEVintersection 2019 in Orlando. I went out to Kennedy Space Center and I got this hat. So that's easy. The source code for this is available if you want to check it out, and I want to step through and show you just one or two things about this real quick. This is Fritz.hat collection. So there are 3 parts to that application. There's the API that runs on the server. There's the client app, which is the Blazor application. And then there's the shared content that travels from server to client, my hats. So if we take a look inside that shared folder, I have a hat object. And the hat has a name, a description, when it was acquired, and the image URL. But on my API, I have just an Azure function that sits out here, has a database repository, and all it does is go into that repository, get the hats, and return them. I have one function that runs on Azure. This costs me nothing to run. The static website itself costs me nothing to run. On a basic service, it's free to run this. When you start to hit a significant number, like millions of requests for the function, then you have to pay a little bit. But just to host this and run out there and support Fritz's hat collection costs me nothing. And it's a simple website, and I've built it with Blazor. It all runs in the browser, and I don't have to think about managing servers and how things are going to run in the browser, because it uses the exact same programming language, the exact same framework front to back, in the browser, out of the browser, on those Azure functions. And I'm referencing that same hat object in both locations. So now my business logic, my skills as a .NET developer become much more powerful, much more portable to take to other platforms. And we're going to see more about this as we get into .NET MAUI coming up in the fall. With .NET 6, we're going to be able to take our Blazor applications, our Blazor pages, and copy them into a .NET MAUI application, and it will compile and run those natively on Windows, Mac, iOS, and Android. So it's very important that if you are a web developer, check out Blazor, get involved here, get a little bit into it. This was a simple website that when you look at the client, it's silly how simple this is, because I have an index page here, and all it's doing with its collection of hat objects is saying, for each hat, format the hat on screen. I wrote a little hat UI component just so I could show how easy it is to build a little component that knows how to format a hat object with the Bootstrap card UI. So I put the name of the hat, I put when it was acquired, and I put a little bit of a description. And I can even put a footer on there if I wanted to. And I think I did put a footer on this so that you could see. I started putting, yeah, there we go, some acquired dates on these. I have a super C# hat there. My Blazor hat is down here somewhere. There it is, Blazor. April 2019, I made that hat. So this is easy for us to do. We know how to do this. You know how to build HTML. You know how to work with Razor. This is where you want to be. Not in my hat application. This is a simple application. But these are the things that you're going to benefit from learning looking forward at the next 12 to 18 months of .NET and where you want to take your career. So I have a couple resources for you as we wrap up here. The WebAssembly specification, if you want to dig in and learn more about how WebAssembly runs, why it's so good in the browser, check it out at webassembly.org. The awesome WebAssembly list, where you'll find the demo for Doom that I ran in the browser, because I know you want to run this on your phone, because Doom runs on your phone in the browser, okay? I did this with Safari. I did this with the Diablo demo. The Diablo demo is at Awesome Blazor, but you can check those out on GitHub. Get Blazor at blazor.net. And you can install .NET 5 SDK and get that running at get.net. Sure, the question for everybody to be able to hear is, when I was showing the counter sample, I had a little bit of a caching issue there, that it didn't reload and present properly. So to be clear, I'm running .NET 6 Preview 4. I'm literally showing you bits that were released 3 weeks ago. So some of the things around the hot reload aren't perfect yet. So it wasn't refreshing the screen completely when I ran that. So if I go back up here, Where was it? DEVint first. And if I .NET run this, so I'm not watching, right? .NET Watch will run and execute your code and re-execute your code every time it changes. So the counter example here was caching for me because the way that .NET Watch runs, it keeps a lot of that code running in the background, and it is just swapping out bits. So having to restart the server because I'm in development mode is what happened there. So thank you for the question. Exactly. We're getting there. It's growing. So there was a question over here on the right side. Yes, sir. Yes. So the question asked is, when I was showing the property that we were passing in here for the counter, I was passing in over here in my counter example, I just passed in an integer here for a parameter. And in the survey prompt, we're just passing in a string. Can we pass more complex objects into our components, into our Blazor pages? Yes, we can, is the answer. If I head back over here, and I'm gonna go back to my hat example. See, I like hats for a reason. Check this out. So this is that hat UI component. Inside my hat collection website, each one of these cards is a hat UI in Blazor. So this is the source code to that component. And inside here, the property that I'm passing in is a hat object. So I've got my domain model. It sounds weird, domain model, and it's a hat. Okay. But I'm passing that more complex object in, and it's using that and presenting it properly on screen for me.